Math concepts are so integral to modern life that many teachers might describe them as foundational concepts that all children have a right to explore. But the language of math presents those concepts in abstract forms that are useful for manipulating the concepts in complicated ways, but can make them seem unfamiliar and unconnected to everyday life. The purpose of this teacher activity is to practice a Reggio Emilia style approach to math curriculum goals, using projects, provocations, classroom environment, and documentation to listen thoughtfully to the students' many ways of expressing the interests in mathematical ideas that have been inspired by their experiences in their families and communities, in order to better understand and support their developing mathematical thoughts, theories, and understandings. Even young children are already immersed in a world that expresses basics such as time, place, value, and even fairness in terms of numbers. Many children also seem to have an intrinsic interest in ideas that are best described using math. For example, comparisons, classification, probability and statistics, and extremes. A Reggio Emilia style approach to math concepts draws out those interests, tries to understand what students are thinking and wondering about them, and encourages them to explore using their 100 languages, which include multiple ways of expressing mathematical concepts, such as numbers, size, shapes, and patterns. Now, what you will actually do in the classroom for this teacher activity will depend very much on your students' current mathematical understandings and interests, as well as your teaching goals. An ideal place to begin is with curiosities and confusions about numbers that your students have already expressed. Before doing this activity, you may want to exercise your role as teacher researcher to discover some of their natural interests in math. Taking a Reggio Emilia approach, this does not mean questions about how to do math work that you've given them. You're looking for genuine curiosities triggered by their own observations of or confusions about the world. Once you have some ideas in mind, you can begin to explore and develop them with the students. For example, at a class meeting, bring up a question or problem that a student has posed, or an argument that you've overheard, and ask for opinions, guesses, and ideas. Ask a question of the day in mathematical terms, or ask for the answer to be expressed in mathematical terms. Set up relevant provocations and observe what the students say and do in response. Change the classroom environment or routine in ways that invite discussion of numbers, shapes, or patterns. As always, you want to act as a teacher researcher during this phase of the process, taking note of what the children say and do that reveals their thought processes. Then you can follow up on their interests and further develop their understandings and yours by continuing discussions over a series of meetings, by setting up further provocations, further rearrangements of the class schedule or environment, or by incorporating the language that the children have been using to discuss math concepts in your curriculum-driven activities, or by developing new projects. What you will need for this activity will of course depend on where your students' interests lie. When doing activities that explore math concepts in the real world, it is always useful to have plenty of standard tools for measuring things in the world, such as rulers, scales, and thermometers. However, from a Reggio Emilia perspective, it's also good to be open to the idea of letting the students develop ways of measuring, counting, or sorting that make sense to them. For example, a class might decide that they want to compare the lengths of school hallways by pacing off distances. The discovery that students with longer or shorter steps will arrive at different measurements, rather than being a problem in a Reggio Emilia context, would provide rich opportunities for exploring basic concepts, such as units of measurement and standardization. It is this type of grounding in personal experiences, of developing problems and solutions for themselves, that helps to build real-world connections to mathematical abstractions. From a mathematics perspective, simple actions such as measuring, counting, and sorting are great real-world starting points that naturally connect an activity to basic arithmetic concepts such as addition, subtraction, division, and multiplication. From a Reggio Emilia perspective, it's best to measure and count things that are part of the children's everyday world, rather than bringing in special math objects. So in general, you won't need specialized materials for Reggio Emilia-style math explorations. Also, your math activities will develop in stages as the class discovers new questions and problems to explore. So there will be plenty of time for you to decide on and gather materials for the next stage. And there's no need to shy away from other areas of mathematics. Again, organizing activities, projects, and provocations that explore and extend their current theories and understandings can help children develop a solid base for building mathematical understanding in many areas, including geometry, fractions and percentages, sets and formal logic, estimation, probability and statistics, number lines, graphs, diagrams, and other languages for expressing number-based ideas. After you've done an activity that includes a mathematical element, you may want to assess and reflect specifically on how the activity seemed to address your current math goals. From a Reggio Emilia perspective, you may also want to reflect on the following questions. What words, phrases, metaphors, visual symbols, or real-world objects do the children use to refer to or express mathematical ideas? What activities might help them explore, develop, or better express their mathematical languages? What ideas or activities pique their curiosity enough to provoke them to volunteer opinions, argue among themselves, or come up with interesting theories? And what can you do to help them explore these interests? What have you learned about the students' mathematical ideas and theories? What understandings have they already developed that have surprised you? And what might be useful areas to explore next, given their current questions, confusions, and arguments amongst themselves? The understandings that your students develop now regarding math in their own lives will help to build a solid foundation for more formal explorations of mathematics in the future.